All right. So what is a system of equations? System of equation is basically two variables with what? I don't know how to spell variables. With two what? Two unknowns. Three variables with what? Three unknowns, and so on. What's the difference in a system of equations and what we've been doing? That's not rhetorical. Usually there's just one variable, and that's x. Those are your one-step equations, you know, that you don't have to worry about. Your linear equations or your, this is going to have x and y. This is going to have x, y, and z. All right? This is important for your physics majors, statics majors, not physics people that take physics, and your engineering people that take engineering, because it's an x, y, z, which is the three-dimensional coordinate system. This is your two-dimensional coordinate system, x and y. So x, y, and z. X, y. And this is x, y, and z. Or as engineering people say, zeta. Zeta. They don't say z, they say zeta. Now, we're not going to worry too much about the three-dimensional. All right? The reason we're not going to worry too much about the three-dimensional is because that's for a lot of engineering majors and science and math majors. All right? Y'all are mostly business majors, or you wouldn't be in the business track. So business majors, you deal with a lot of the two-dimensional graph, usually in the what quadrant? The first quadrant, because most businesses like to stay in the what? Positive. So most of the time you're going to be dealing with charts in the x, y coordinate, usually in the first quadrant, unless your company sucks. And then you'll be in the other coordinate, over here, which means you're losing money. All right? So we're going to stick with the two coordinate system. You don't have to draw this. That's just my little part. All right. The first way to solve a system of equation is the most inaccurate is by what? Graphing. The reason it's the most inaccurate is because people suck at graphing. They don't. Have you ever watched students? When I say graph this, y'all just take a pencil and paper and you just do that. You won't even use a straight edge. You won't even use graph paper. I mean, this comes out to where y'all don't even. I mean, not y'all. Students don't even take it seriously. They just draw graph. Back a long time ago, you didn't draw a graph unless it was on graph. And you've gotten away from that. And that's why graphing has become the least accurate, because a lot of students really don't know how to graph correctly. And that's why. And now the graphing calculators have made it worse because they depend on more. There's nothing wrong with using the graphing calculator to check it, but you need to know what you're doing. The second method is substitution. Substitution, you solve one variable, plug and chug into the other equation. Some people like this because they just like to substitute. I remember when I was in college algebra, I liked it because it's the only one I could understand. And I used it. Third is elimination. Elimination is when you use algebraic manipulation to take out a variable and leave the other variable. So therefore you have one equation and what? one unknown, so you can solve it. Elimination is probably the most algebraic, because you have to manipulate it. 4, Kramer's rule, using determinants. We don't get into that, but I'll show you a quick version of it just for your information. And then 5, matrices. And I'll show you an example of a matrix. The reason I'm showing you 5 different methods is, you may have learned all 5. You may have learned just 2. I don't want you to get confused when you see the different methods. I don't want you to think, well, am I doing the right thing? So let's go ahead and take a look at one. I'll just make one up, and we'll do it those different ways. 2x plus 3y is equal to 6, and negative x minus 5y is equal to 2. Now, I have no idea what these two look like. I hope they're not parallel or perpendicular or anything, but I just made them up, so let's just see what we can do. So let's graph them. I'm going to make one of them blue, make that one blue, and I'm going to make this one red. And I want you to graph both of these lines. And you're going to have to use graph paper, and I'll tell you why. Because it's the least accurate, and you can't just sketch them. And you're going to have to use a straight edge. I'm going to have to up here, because there's no way you can get it by sketching. Unless you're like a Rain Man or something. So let's turn on our graph. And let's see. Let me see if I wouldn't give him any graph paper. You can't bring no graph paper to class. I'm uninstalling it, and I'm going to reinstall it, and that way I can put your 83 on there, okay? No, it shouldn't, but I don't know why it's... I don't want that. I don't know why it won't come up. There it is. I got it. Oh. Your device isn't compatible. That's why. That's why you can't get it. That's why. That's why, because when I finally found it, it's got a little rabbit, and I tried to download it, and it said yours is not compatible. I knew there had to be something wrong. Okay, now this problem, if you did it by graphing, I would use the x-intercepts. Why? X and y intercepts. Because x and y are not what? By themselves. Oops. What the heck happened? Oh, I hit that button. So my y-intercept, my x-intercept, we'll do it in blue. I meant my, yeah, we can do the x-intercept. X-intercept, 0 for y. Y-intercept, 0 for x. X-intercept, 0 for y. Y-intercept, 0 for x. So if I plug in 0 for y, what am I going to get for x? If I plug in 0 for x, what am I going to get for y? So that should be your two intercepts there. How about over here? If I plug in 0 for y, be careful. I'm going to just put my pencil over that x because it goes away. What are you going to get? -2 what? Divided by 5. Solve for y. What about if I plug in 0 for x? You're going to get x is equal to what? -2, Hubert. Yeah, that's right, class. Y'all should know how to do it.
I'm confused.
I'm Hubert. What are you confused? Now we went over this in chapter 1.
Wait, the one you were doing before, the first one you were putting 0 in place of y?
Always. When you find the x-intercept, I don't care if you're in marketing, business, trig, I don't care. If you want to find the x-intercept, you plug in 0 for what? Y.
I think, I'm not sure. I think that says that the x-intercept is -2.205.
This is the x-intercept. This is the y-intercept.
And for the red one,
Same thing. This is the x-intercept.
it seems like it's backwards though.
It is. When you want the y-intercept, you plug in 0 for x. When you want the x-intercept, 0 for y.
No, I mean the answer is backwards. I mean, it's like plug in. You want the x-intercept, plug in 0 for y.
Yep.
So
So the 3y goes out.
I'm talking about the second.
So the 5y goes out. And that leaves negative x is equal to 2.
But
And-
wouldn't that mean that x equals to negative 2?
That's what I got right there. Plug in 0 for x. Y is equal to negative what? Oh, I do have it backwards, don't I? Do I? Hold on. How did I do that?
I was looking at it.
I suck. Thank you, Mr. Klauser. You're the only person that said anything. Don't say nothing. If you said, oh, I was gone, shut up. I don't want to hear it. I'm just kidding. All right, I got to erase. I don't know how I did that.
Something doesn't make sense to me. I ask questions.
Okay, Mr. Klauser, you're rubbing it in. You're going to fail.
Whoa. No, I was just.
I'm kidding, Mr. Klauser. You got to realize, Mr. Klauser, I kid. 0 for y, you get negative 2. 0 for x, you get negative 2/5. How's that? Does that look better? I got to blame somebody, so I'll blame the pen. I'll blame the mouse. All right, so here we go. I'm going to make my dot real big. And, excuse me. Now, why do I put x and y over my intercepts? So I don't plot on the wrong what? Axis. That's why. So 3 and 0 is going to be in my x-axis. So 1, 2, 3. Really? 1, 2, 3. And see, you got to be right on it. You can't be, in fact, I'm going to hit snap the grid. And there's that one. And the next one is 0, 2. Oh, that didn't snap the grid. Oh, look like it did. I don't think snap the grid's on. Yeah, it is. Okay, so my line, take my handy dandy line maker. Looks like that. My line's a little bit out because I have to snap to those 2 points, but that looks like the line right there. And then the other line, negative 2 and 0. Negative 2 and 0. And that still don't look like it's snapping. And 0, 2/5. Negative 2/5 on the y. 0, negative 2/5 is about 1/2, right? So right in there. And if I draw a line with that one, I'm not going to be able to. Looks like something like that. Now do you start to see why graphing is so inaccurate? Now what are you going to do? Well, here's purple, or I'll make it, or I'll highlight it. Here is my what? There's my intersection point right there. But what's the problem? It's right in the middle of a box. And some people are like, I don't know how to graph that. Why? Because they've never had to graph anything like that. So that's why you see people not using the graphing method, because it is the most inaccurate. There's your intersection point. Now, what does the intersection point represent? I love asking that question because you've done it, you know how to do it, but what does it give you? I mean, what does the intersection point give you? It gives you an X and Y that will work in what? Both equations. That's what it gives you. It gives you the solution to both equations. So this X is 1, 2, 3, 4, 5.5, and 1.5. I'm going to say 5.5 and 1.5. Somebody write that down because I'm going to forget. All right. Now, how do we know if it's right? Well, you graph it on your graphing calculator. Or you do the substitution method. And that's what we're going to do next. The substitution method. You know how I can make $1 million? If I could invent a little hat that could read my mind and work this thing, I'd be a millionaire. Like that guy that the physics guru that's in the wheelchair, Stephen Hawking. Some of his software he can look at, and it follows his eyes, and he can pick out words with his eyeballs. Isn't that neat? That's what I need to invent. I wish I could invent something like that. And Lord, I would be in trouble if I had money. I'd spend all of it. Okay, nobody's going to elaborate on that. Y'all couldn't spend some money. I would go to Atlanta, a place called Atlanta Equipment Company. I'd buy me a brand new Caterpillar V8 and a Caterpillar track hoe, and all of them had air conditioning. Maybe a TV, I get bored, I can watch the news.
That's when I got birthday or Christmas month. Like,
You spin it.
well, actually, sometimes I have difficulty deciding on what to spend it on.
I don't know. If I ever win a lottery, y'all will know it. Because I'll drive up in a brand new 3500 Dodge. You'll know it. Or you'll know my wife and my ex-wife got married. One of the two. All right. What was the two problems? What was the red, blue? What? 2x. And the red? Equals what? 7? Oh. Well, you... Done. All right. What do you want to do with substitution? You need to solve for a what? Variable. Which one of these two would be the easiest to solve for a variable?
red one.
The red one, yes. For what? X. So do that. Now, is your dad the one that went to check with me? Okay. Y'all still got any cows? I thought y'all had cows. Y'all did. Amy, which one? Is that your dad? Okay, that's the one. Yeah, we used to be in Pool 101 together. Pool 101. You know where the cafeteria is up there, Phil? And you know where you go up that ramp? And there's an advising center right there. That used to be the pool room. That just used to be just the floor, and it had chairs around it, and had 3 pool tables there. No, that's where we all cut class and went there. That's why it took me like 3 years to get a 2-year degree. Called Pool 101. We even had a cooler up there there was a pinball machine and some video games in the little room back there. And we had a cooler in there full of refreshments. We were bad. Alright, so negative x is equal to 5y plus what? 2. Now, of course, Andy didn't have anything to do with all that. He was straight in there. And x is equal to what? 2. Now, what are you going to do with that negative 5y minus 2? Good job. Split it into x. So right over here, I'll take my handy dandy blue marker. And I'm going to plug in negative 5y minus 2. And finish it. I got up this morning, I got my son this week, he wanted grits. So I made grits, and I had some left over. I've been eating on these grits all morning. Alright? So, what's 2 times negative 5y? Negative 10y. Negative 2 times 2 is what? Now what's negative 10y plus 3y? And I'm going to take that 7y where? I'm going to take it over to the right side because I don't like negative what? negative variables. So negative 4 is equal to 6y, or 6 plus 7y, minus the 6, you get 7y is equal to what? Negative 10 divided by 7, divided by 7, y is equal to negative 10 sevenths. Okay, now what are you going to do with y? You're going to BS your way through the rest of the problem. And BS stands for what? Back substitution. Right? So, go ahead and let's take this guy and copy. Let's go to the next page. And we got y is equal to negative what? 10 sevenths? So I'm going to rewrite the red, and I'm going to say negative x minus 5 times parentheses equals 2. And that negative 10 sevenths goes right here, because now is what we call back substitution. Now the reason I'm telling you, making a big deal out of that word, is because in systems of equations, that's what you're going to hear a lot. Back substitution. Back substitution. You're going to hear it in matrices, you're going to hear it in substitution, you're going to hear it in elimination, so that's why I just wanted to say back substitution. So negative x plus 50 over 7 is equal to what? 2. Well, I'm going to bring my x over because I don't like fooling with negative variables. So I'm going to bring that x over. And I get 50 over 7 is equal to x plus 2. Now what? Minus the 2, and that's minus 14 sevenths. Minus 14 sevenths. So x is equal to, what's 50 minus 14? Dang old 36? So, our point of intersection is 36 sevenths, which is what? 7 will go in there, what? 5 and 1 7, comma, 1 and 3 sevenths. That is the solution. Now you look back at your graph. One, 2, 3, 4, 5. And I said 5.5. What did I say? 5.5 and what? Negative 1.5. 5.5. No, not one. Not a half, but 5. I got that right. And then 1. That should be negative. Now you're going to do elimination and check back. So really, one of the classes I used to teach was 102, which is the one that goes into 110 in this class. And I used to and I used to do all 5 methods, and for your test, you would have to do a notebook. And you would have to do all 5, do one question, and I'd write the question on the board, and they would have to write explaining how to do each method. And that's the notebook they would have to turn in, and that would be the test. And that would be systems of equations at units will do that. And, but I don't do that anymore, so. People complain they have to do a little bit of work. So let's do elimination. And now hopefully most of you have seen all of this. So elimination. And I'm just going to go back here. See if I can grab those two. There they are. Now, let me give you some things to remember about elimination. The first thing you need to remember is look for equal coefficients. 2, look for opposite signs. Now, what you need to do right now is put these 2 over each other. Whenever you do elimination, this is your first thing you do. Take this guy and you put him right under this guy. Doesn't matter which one goes where. It doesn't matter. And now you look for the same coefficients and opposite what? Signs. Where do you see opposite signs and you don't see same coefficients, so you can't do same coefficients, but you can do opposite signs for these 2 and these 2. Which one you think I'm going to pick? You think I'm going to get rid of the X or I'm going to get rid of the Y? Get rid of the X. Why? KISS method. What's the KISS method? Keep it simple. If I got rid of the Y, I'd have to multiply the top by 5 and the bottom by 3. If I get rid of the X, I just got to multiply the bottom by what? 2. So let's keep it simple. So multiply the bottom by 2. So I'm going to take my handy dandy purple marker and I'm going to multiply this by 2. And when I do, my blue, I'm just going to, is 2x plus 3y is equal to 6. And then my red becomes what? Negative 2x minus what? 10y is equal to what? What is the most common mistake students make on this step? Anybody want to take a guess?
Multiply all. They forget to multiply the whole thing.
Yes, and they don't do the 4 on the end. They put 2. That is the most common mistake. Now, what happens here when you add the 2 together? What happens to the x's? They eliminate. Thus, the elimination. All right. What is 3 minus 10? Negative 7y is equal to what? Oh my, look at there. Y is equal to what? 10/7. -2. -10/7. And that's what we got in the previous problem.
Wait a second.
Sorry, that was incorrect.
Negative, oh,
Doesn't matter where the negative is, it's still negative.
okay, negative 7y. What about the equation stuff? Oh, 10.
Okay. Now, how do you get, that's y, how do you get x? BS your way through it. Back substitute. Take the y and plug it in where? Right here. So, I'm going to do -x minus 5 parentheses equals 2, and plug in negative what? And that's what we did a while ago. You get -x minus be plus 50/7 is equal to 2. And remember, we changed this into 14/7. Y'all remember that? And take the minus away and all that, you're going to get the same thing. 36/7 or negative, which one is it? It's 36/7. X is equal to 36/7. A lot of people say, well, why did you do those? Whose is this? Is this yours, Mr. Clouser? You're the only person that came up here, that's why I was wondering. Okay. A lot of people say, well, why did you do the folder? I said, well, because a lot of people didn't know how to do each thing and they get it all confused. But think about it. If I give you one problem on the test and I tell you to use all the different methods, what should you make on the test? 100, because you shouldn't get it wrong unless you just don't have a clue how to do each method. Because all the methods will give you what? The same answer.
So if it says use the substitution, if you want to use the elimination, go ahead.
I don't care. I don't really care.
I don't have a test, obviously.
Yeah, online, I don't care what you use. I just don't want you to just use calculator. I want you to be able to do this. So, but I can't, you know, that's like giving a haircut over the phone. I can't make you do. Okay, you got it? You got a question? I'm going to put another one on the board. Well, I'm going to put another one on the board yet. I want to show you matrix. Kramer's rule, matrix, whatever. Kramer's rule. Irritating. Be positive. You gotta divide through by -1 because the x is negative. Or no matter how you do it, you're gonna get a positive 36/7. Remember, look at your graph. The graph is positive x. All right, Kramer's rule. You're gonna first of all, you're gonna set up a matrix, and the initial matrix is gonna look like this. What was it, 2x? 2x plus 3y is equal to what? So 2, 3, 6. And then what was the red? Negative x, that's -1. And what's the rest of it?
-5.
-5 and what? 2. There's your matrix. All I did was take away the what? The X and the Y, that's right. The X's are in this column, just put your little X right there, and the Y's are in this column, and this is your answer column. You don't have to write that, I'm just letting you know. In matrices, there's an X and a Y column. Now, the way that you do Kramer's rule is by use of determinants. Determinants. A determinant is a 2x2 matrix that you set up using those 6 numbers. The first matrix, the first determinant, I'm going to call the denominator determinant. The determinant of the denominator. And the next one I'm going to make up is I'm going to do the determinant of x numerator. Put an N there if you want to. And the determinant of y numerator. Now you're not going to see this in any book. This is Hubertism. This x, this d, and this x n, and this y n. That's what I do. A-N-T-S, like ants. I hope I spelled it right, like that, and y'all can look it up. All right, now I want to make sure everybody's got it written down before I do set up each one, because I want to make sure everybody's watching. This is D of D. This is D of X N, D of Y N. We're going to make up 3 2x2 matrices. The first 2x2 matrices is going to consist of these 4 numbers right here. 2, 3, -1, -5. Okay, everybody got that part? All right, now watch. I want my X numerator, so I'm going to take my X column. And of course, it's not going to let me do it, but I'm going to take it out. I'm going to move it over here on the side of the page. Okay, in other words, I'm going to move it, and I'm going to take these 2 guys and put right there, and there's my new matrix for this. So 6, 3, 2, and 5. That's just the way you do it. And then when you get the Y, you plug these guys in for the Y. That's what I'm fixing to do next. So I've got this matrix. So I put this back. Oops. I put everything back the way it was. Sorry. Put this back over here. And I put this back over here. All right, now I'm going to set up my third one. I'm going to take my Y out. and plug in what? My 2 and my 6 right there, and there's my third matrix. 2, 6, -1, 2. And now you just have to find the determinant. And what's the determinant? Well, just remember a fish. Just remember a fish. 2 times -5 minus, that's the minus, that's the amount, 3 times what? -1. Do that with each one of these.
So what y'all think about that chick in Virginia? Hmm? You think she's dead? Huh? Yeah. The one that's missing? What'd she do? Why'd she quit? When did that happen? I was talking about the Virginia college student. I'm just curious, how many of y'all have heard of ISIS?
The group?
Yeah, I just wondered because they were doing a news show the other day, and the guy went out on the street at one of the colleges, and they had no idea what ISIS was. I'll shut up. Y'all were working. I'm sorry, what?
There was a student in New Jersey who went hiking, and he died with a bad wound.
He must have been one of those opponents of gun control.
New Jersey? Why is it always New Jersey?
It's Chris Christie's fault.
Why is it always Philadelphia? Why is it always Chicago? Why is it always a car wreck? Why is it always pneumonia?
Who knows?
So one time I was reading a Lois Duncan novel, and
Let me go back right quick and move this back over here. This back over here. this right there. Now, a matrix, sorry, you want to try, what you would like to have in a matrix is, and I'll put this in, well, I'll just say what you want. Is called basically the matrix that looks like this. Okay? In other words, when you have a matrix that looks like this, you want to get it to look like this. And when you get it to look like this, you're done. Because what does this say? This says 1x is equal to a number. What does this say? 1y is equal to a number. And what you do, you remember how we did elimination and we multiplied by 2 and we got rid of the x and the y's? Well, that's what you're going to do kind of here. You're just going to do it several times. For instance, if I want to get a 1 right here, what do I need to do? I either need to subtract 1 or I need to divide by 2. Well, you don't subtract in matrices. You can, but that's another unit. All right? So I'm going to divide the first row by 2. So I'm going to write row 1 multiplied by 1/2, or divide by what? 2. And that gives you new row 1. So what is 2 divided by 2? 1. What's 3 divided by 2? 3/2. And what's 6 divided by 2?
Wait, 3.
And there's our new matrix. And we have our 1. That 1 right there, we've got it right here. So we've got one of them. We've got 3 other numbers, 2 other numbers to get rid of, and then another one to make into a 1. So now I want to get rid of this -1.
How did you know to multiply each one by 1/2?
How do you get a 1 right here? You either subtract 1 or you divide by 2. We want a 1 there. There's only 2 ways to get a 1 there.
Oh,
1, you got to subtract 1, and 2, you got to divide. But you don't subtract the matrix. So you divide. Now, how do I get a 0 here? Well, I've got to add 1 to it, right? Now, after you get the same coefficient here, you can add and get rid of this. And that's what you do. So what do? You take row 1, and I'm writing it out because you might want to play with it. I don't know. Row 1 multiplied by 1, add it to row 2 to get new row 2. Just like elimination. Now, you technically don't have to multiply it by 1, but what if this was a 2, a -2? Then you'd have to multiply this by 2 and then add it to row 2 to get new row 2. So I've just put that there just so you can remember you can multiply. But you're going to get 1, 3/2, and 3, and then you're going to add -1, -5, and 2. And what happens here? There's that 0 we need. We want a 0 here, so that's how we're turning this -1 into 0 by doing this. 3 halves, well, this has got to be changed to negative 10 halves. So, what's 3 halves minus 10 halves? Negative what? 7 halves. And what's 3 plus 2? 5. So our new matrix is 1, 3 halves, 3, 0, negative 7 halves, and 5. How did I get a 1 right here? Multiply by the reciprocal, which is what? Negative what? Negative 2 over 7. So row 2 multiplied by negative 2 over 7. So 1, 3 halves, 3. What's 0 times 2 sevenths? 0. What does that make? Negative 7 halves times negative 2 sevenths? 1. And what's 5 times negative 2 sevenths? Y'all recognize any numbers? Y is equal to what? Negative 10 sevenths. Now how do you get rid of a positive 3 halves? No. You can't do that. You'll annihilate the whole row. Subtract 3 halves, and the only way you can get that is by taking row 2, multiplying by negative 3 halves, and add it to row 1 to get you row 1. So what I'm going to do is I'm going to take this, and I'm going to copy it, and go to the next page, and bring it over here. And I'm going to write it down. I'm going to take row 2, I'm going to multiply by negative 3 halves, and I'm going to add it to row 1 to get new row 1. So negative 3 halves times 0 is what? 0. That's negative 3 halves. And what's negative times a negative? That's a positive. And that's 30 over what? 14? Is that right? And now I'm going to add it to row 1. 1, 3 halves, and 3. And that'll give me a 1, a 0, and I'm going to change this to 14 times, let's see, what is that, 42 over 3? 42 over 14. What's 30? Something on right there. Okay, I must have flipped. Yeah. Where did I do that? Where did I mess up? Right here? Okay. So it needs to be what? What needs to change it into what? Not 21 over 14. What did I have here? We have 3. Well, we'll finish it next time. Y'all about ready to go because y'all already doing the zipping thing. So I'll stop it here.